Hi everyone, in this video I'm going to demonstrate on how to design a portal frame. Go to Files menu, New Project, then select the template for, then declare the dimensions and declare the support. I will choose a pin support, and there's also an option for a single frame or multiple. I will choose a single frame, then copy the frame later, then click OK. Then I will go straight to the model. Okay. This is now my initial frame. Then I will copy this frame and create an array along the Z direction. Then declare the number of quantities. I will say it's 3, then spacing of 5, then click apply. Now I have these 4 identical frames. The next thing is to add elements such as beams or lateral bracing. Click these two nodes elements, then click the nodes connecting the members, then right mouse click, then add elements or beams in the middle, right mouse click, then add the beams to the right mouse click, then add the lateral bracing, here click the nodes, now I'm done. Okay, then exit. Now I have this model. The next thing I will do is to designate the section properties of these elements. Before doing that, I will add material section to my section library by clicking the materials menu, add button, and then add button, then select trial sizes for my members. And OK. And then this one, OK. Now I have here 3 different sizes of white plants. Then I will add one more, a user-defined steel section, circular one for my bracing, 25 millimeter diameter. Then click OK, and then OK. Now what I need to do is to designate the section properties by selecting the elements. I will select the girders and then right mouse click, edit beam properties, then choose my trial size for that elements I have just selected. Apply. Then you can see here, next I will select the columns, then right mouse click, edit beam properties, and then select trial size. Well, this one I still have to change. Apply. Then for these elements connecting the frames, right mouse click, edit beam properties, then apply. Next is my cross bracing. Then right mouse click, edit beam properties, then 25 diameter. Then for cross bracing, the member type should be a tension member, meaning the element can only carry a tensile load. Apply. Now this is now my model. The next thing I will do is to select the support nodes, and then right mouse click, edit node properties, and designate the nodes as a footing, and then declare the restraints. Now this is our pin support, so the X, Y, and Z displacements are fixed, but the rotations are free. Then apply, exit. Now this is now the model. Then the next thing I will do is to create the load cases in the model. So go to loads menu and then create button. By default, there are two load cases, did load and live load. So I have to add other load cases such as the win load and combination cases. So add load case button, and then I will type the load case name, say for example win load 1. Then because it's a win load, I don't have to include the self weight. Then add button. Next, I will add another win load case, say for example win load 2. Add. Then I will add a combination load case, say for example 1.2 did load plus 1.5 live load. Then declare the load factors. I will add another load case combination, say for example 0.75 did load plus win load 1. So 0.75 and 1.0. Another load case combination, say for example 1.5 did load plus win load 2. So 1.5 and then 1.0 in W2, then add exit. Now I have all the load cases that I want. Next thing is to apply different loads to the elements, and I prefer to hide some of the elements that I don't want to see, so I will create layers. Click the elements menu and then create layer button. Then I will type the names of the layers. Say for example, girder, add, then column, columns add, then um, bracing, add, then close. Now I will populate the layers with the member of the elements or the elements that belong to the layer. So click the populate button, then select girder, then I will select the members that belong to the layer called girder. Then click apply. Now those elements that I have just selected now belong to the girder layer. Then columns, I will choose the members that belong to that layer. Then apply. Okay, then I will select the bracing, then select the bracing. It's too small, so what I will do is to click apply and then okay and then close. Then I will just populate layer, bracing. That's easier with the stick model. And then okay and then apply, then okay and then close. Now if you go to view layer, I can hide some of the member. Okay, I think one of the girders were designated in the bracing, so I have to change this. So I will choose the girder and then select this one and then apply, okay, then close, then view. Now I have correctly changed the layer of that girder. Then I will hide all the elements except the girder and then select all the girders and then right mouse click, apply element load, then add the load value. Okay, now exit. Now loads, I can change the load graphic scale. Exit. Now I will go to live load and then the same thing, I will select the girders, right mouse click, apply element load, apply and then exit. We'll add the win loads by going to win load case and then showing the columns as well, because the wind loads also act on the columns. Then select the columns, then apply wind loads by right mouse clicking, apply element load, declare the values. So it's going to the negative x, apply. On the other side, I will select the columns and apply the wind loads, assuming it's going to the positive direction. Then apply. Then for the girders or the roof beams, the loads are acting perpendicular to the axis of the beam, so I should declare the loads as local type, then apply the values along the major axis. So I will assume it's going upwards, so positive 25, apply. The same for these 4 girders to the right, 25, apply, then exit. Then I will declare wind load case number 2 or WL2, then apply the loads in the columns, right mouse click, apply element loads. Then this time I will assume that loads are acting towards the positive x, then apply. Then for the other side, I will assume it's going to the negative x direction. Then for the girders, local load type and then downwards, then apply. Now I have the dead load, the live load, the wind load case 1 and wind load case 2. Next, I will show all the elements by going to the layers menu and view, then tick all the boxes to show all the elements. Then I will hide the element loads. Now I noticed that I need to have a column in this area here to the from the middle of the girder down to the ground level. So what I need to do, because I don't know the height, what I only know is that it should be level to the other columns at the base. So I will create a temporary element connecting these 2 nodes, and then divide this element equally, then connect the 2 nodes from here, assuming column, then connect node here, right mouse click, exit, then delete this temporary element. Next, I will declare the boundary condition of this node, by selecting this node and then right mouse click, edit node properties, hence, and then footing, apply, exit. Then I will copy this element to the other side. So select this element, right mouse click, copy element, select the reference node, and then OK, and then select the reference node, OK, and then select the destination node, OK. OK, now I have the column to the other side, and then declare the support in this node, right mouse click, footing, hence, apply, exit. Now I have two new columns on both ends of the building. Next, I will add the cross bracing. Cross bracing, so it should be tensile member or tension member. Then select the size, then create the element here from this node to this node and this node, right mouse click. Then I will create or add a cross bracing from the other side, here, 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 right mouse click, exit, and then I have now the model. So what I will do is to analyze the structure. Click the analysis menu, and then FrameCE will do all the calculations for the displacements, shear, moment, axial forces, and so on and so forth. So if I go to dead load and want to see the deflection due to dead load, this is what I see. If I want to see the deflection along the x-axis due to wind load, this is the deflection. Okay, and then if I want to produce a report of the analysis, then click this report button, select the load cases to give a report, click OK, and then select all if you want to show all the members in the report, or you can unselect some of them if you don't want. So I'll just use I'll select all and then click OK. Then FrameCE will produce a PDF format of the summary report. So this is now the analysis report. It shows every element, the moment, the shear, and for the load cases that I have chosen. Next, I will now design. So to design, go to design menu, and then linear elastic, OK, and then select the loads that will produce the design, or select the loads that will be used for the design, then OK, and then select the members to be designed. So I will assume that all the girders will have the same size, so I will select all the girders and then click individual design, OK, and select W shape. Then FrameCE will ask if the element or the members have lateral support or not. I will assume the girders have lateral supports. Okay, yes, yes, and then FrameCE will allow you to choose your design size. So just choose from the from the allowable sizes displayed from the template. Then do an iteration until you will get a safe design. So okay, now it's safe. So if you want to have a printout of the design, click the main menu and then save as PDF to have a copy of the design. So I will save the design calculation and type the name as girder. OK, and then accept the design. Next, I will design the columns. So I will select the columns and then individual design, W shape. Yes, 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 yes. And then I will find a safe section. It's not safe, so I will go to the next size. Now FrameCE iterates the calculation by checking its loads considered in the design. So that's why it takes a bit of time. Now it's safe. Then I will save the design as PDF. Save and then accept. So if I want to see the calculation, I can just open the PDF file of the design, as you can see here. Then I will design the other columns. The same thing, click the individual design. Yes, yes, and then select a safe size. It's safe, then accept. Then I will design the beams. Then individual design. Yes. It says here, it's say, oh, not safe, so I have to find another size. Now it's saved, so I will save the calculation as PDF. Then accept the design. The next thing I will design are the footings. So I will select the footings. If I want to have the same size for all these footings, then I will select them all together. So in this example, I will assume that all the outer footings will have the same size. So I'm selecting all the outer footings and then design. I have to declare the ultimate swell bearing capacity. And then FrameCE will do the design. It starts from a small footing until it becomes safe by gradually increasing the size. Then main menu, save the design calculation, and then accept the design. Now go back to model. Then I want to see the report of the design, so I will click this report button, select all, and then OK. Then FrameCE will produce a design schedule for all the elements. So this is for the stele members and the footing and the reinforcement. Okay, and that's it. So I hope you learned from this video, and if you have some questions, you can post it in the Facebook page of FrameCE. And by the way, if you want to design the purlins, you can go to design menu and templates, where you can design the purlins. You can have either C or Z purlins, and there is a template for this. You can use this for the purlin design. There's also a purlin design for open weave. As you can see here, you can use this for your purlin design. Close, and then that's it.